Hello, my name is Maria Miller from mathmammoth.com. In this video we're going to study divisibility rules or divisibility tests as they are also called. You probably already know about these. A number is divisible by 2, or it's an even number, if it ends in 0, 2, 4, 6 or 8. And then if it's divisible by 5 if it ends in 0 or 5. Children learn the skip counting pattern of 0, 5, 10, 15, 20, 25, 30, etc. already in first or second grade. And then it's divisible by 10 if it ends in 0, such as 40 or 60 or 100 or 1000 or 1200. And then it's divisible by 100 if it ends in 2 zeros, okay? Or if it would be divisible by 1000 if it ends in 3 zeros, and so on. Let's look at some others now that you might not be familiar with. One is, a number is divisible by 3 if the sum of its digits is divisible by 3. Let me show you what I mean. Let's say I have a number here, 358. I'm going to use this to check or test if it is divisible by 3. So I will take the digits 3, 5 and 8 and add those, okay? I will add 3 plus 5 plus 8. And that's 16. Now I check if 16 is divisible by 3. It's not. So this number is not either. Over here I would add 1 plus 5 plus 7 plus 2. So there's 6, 13, 15. The digit sum is 15 this time. Is 15 divisible by 3? Yes. So this number is also, okay? You can, if you don't believe me, check it by long division. 3 goes to 15 5 times, to 7 2 times, and to 12 4 times, and it's even. Okay, a very similar one for 9. A number is divisible by 9 if the sum of its digits is divisible by 9. Again, if I have a number I want to check if it's divisible by 9, I add the digits. 1 plus 2 plus 8 plus 5 plus 3. So I have here 10, 16, 19. The digit sum is 19. That's not divisible by 9, so neither is the number itself. Or here, 1 plus 6 plus 1 plus 2. I get 7, 8 and 10. Okay? No, that's not divisible by 9 either. Okay? And you could again check it with long division. You would get the remainder. The proofs for this are not very difficult if you have studied algebra, but I don't have time to go into those in this level. Another one, a number is divisible by 4 if the number formed from its last 2 digits is divisible by 4. For example, if I have 124, I just look at the last 2 digits, the 24, that's all I look at. Is 24 divisible by 4? Yes, and so therefore is also 124. And the reason for this is fairly simple, because 100 is divisible by 4. So then when you start skip counting by 4s after 100, you get 100, 104, 108, 112, 116, 120. It is the same skip counting pattern as if you had started at 0. 0, 4, 8, 12, 16. Okay? But it just has the 100 in front, 100, 12, 116. So you just have to look at the last 2 digits. Okay? And the same would of course happen when you come to 200, because 200 is divisible by 4, so then 204, 208, 212, 216 and so on are divisible by 4. Over here, is this divisible by 4? Just look at the 82. Is 82 divisible by 4? Okay, well maybe you don't know. Can you find any number nearby there that is divisible by 4? 80. 80 is divisible by 4, right? And so 84 would be divisible by 4, but not 82. A number is divisible by 6 if it is divisible by both 2 and 3. So we need to check if it is an even number. And then, if it's even number, also check if it is divisible by 3 by using this rule here. Okay, this one is an even number. That one is 2. They are both divisible by 2. Is this one divisible by 3? I now add the digits. 7 plus 1 is 8, and then there's 3 8s. Okay, 24. 24 is divisible by 3. So is this number 2. and so therefore it was also divisible by 6. Here I add the digits to check if it is divisible by 3. I get 9, 10, 14. 14 is not divisible by 3, so neither is this number, and so neither is it divisible by 6. And for 8, a number is divisible by 8 if half of it is divisible by 4. I hope that makes sense. You know, if you take half of it and that is divisible by 4, then when you double it, it gets times 2. You have this 4 times 2 equals 8 there. So 180, let me take half of it. That's 90. And check if that is divisible by 4. Is 90 divisible by 4? Okay, 80 would be, and 84 and 88 and 92 would be, but 90 is not. So this is not divisible by 8. Okay, 280, I'll take half of that. That's 140, okay? I'm looking at 140. I take 140 and check if that is divisible by 4. Is it? Okay, my test for 4 was I look at the last 2 digits, 40. Yes, and so this is divisible by 8. Lastly, let's look at a few numbers here and check if they are divisible for all of these, 2, 3, 4, 5, 6, 7, 8, 9, 10. Using our divisibility rules. And we have a rule for every single one of those numbers except 7, and there is a divisibility rule for 7 too, also for 11, but they get more complicated, and I don't actually even remember the one for 7. So we will use long division for checking 7. First of all, 2. Is this number divisible by 2? Yes, it's an even number. And is it divisible by 3? I need to check the digit sum. I need to add these and check if that's divisible by 3. When I'm doing that, when I'm adding the digits, I can actually omit any digits that are already divisible by 3. Okay? I just add 8 plus 2 is 10. 10 is not divisible by 3, so neither is this number. You see, 10 plus 9 would be 19, and that's not divisible by 3 either. Or if I add 6 more, it won't be divisible by 3. Then by 4, okay, I check 82, the last 2 digits. Now 80 is divisible by 4, so 82 is not. And this is not divisible by 5, because it doesn't end in 0 or 5. It cannot be divisible by 6 because it already wasn't divisible by 3. And now 7, which we're gonna check with long division. 7 goes to 69 9 times. 7 goes to 68 9 times. But to 52 it doesn't go evenly, so it's not divisible by 7. Is it divisible by 8? Okay, well, it cannot be because it already failed at 4. If I take half of this number, that will end in 1, okay? And that's not divisible by 4 either. You can see it that way too. It cannot be divisible by 9 because it already was not divisible by 3. And it's not divisible by 10. So that's all for that. Over here, this one then. This is not an even number. Now, is it divisible by 3? I'll add the digits. There's 1, there's 4, 9. 9 is divisible by 3. 9 is also divisible by 9, so this is actually divisible by both of those. Then it ends in 5, so it is divisible by 5. Okay, it can't be divisible by any of the 2, 4, 6, 8, or 10. And so 7 is the last one to check for that number. We get here 1s. 4 times 7, 28. Over here 5 times 7, 35. And then there's 65. 7 doesn't go evenly to 65. So no, it isn't. And then we're done for that number. And then this big number. Okay, it's an even number. Divisible by 2. The last 2 digits here, 0 and 4, is divisible by 4. Okay? And 3. Let's add this 16, 17, 21. The digit sum is 21. That is divisible by 3. But the digit sum 10, 21 is not divisible by 9. Okay, so it's not divisible by 9. Not by 5. By 6. Yes, it's divisible by both 2 and 3. Okay, and 7, we will check here. Goes once, goes twice, there's 60, lastly 44, but no, it doesn't go evenly. Okay. Then we just have 8 and 10 to check. It's not divisible by 10. And then the 8 situation. I would have to take half of this and check if that is divisible by 4. However, I think it is equally quick to just divide this by 8 and check if it is even division. Okay, 7, 1, 8, 1, 0, 4. And divide by 8. Goes to 71, 8 times. Goes to 78, 9 times. 61, 7 times. And to 50, 6 times. Lastly, I will get 24, which is an even division. So yes, it was divisible by 8. Okay. Now we're all done with this, and I hope this was helpful.